So 10% two-tailed is, and it's 10 over 30, never mind. Okay, so for two-tailed, it's 0.3061.
Okay.
So 0.45 is greater than 0.3061. So you reject the null hypothesis.
So there's sufficient evidence to reject null hypothesis and accept the alternate hypothesis. Just check. So it's not equal to, so it's two-tailed. That from the table, critical values 5%, sample size 30, plus or minus 0.3061. This one, the observed value of R lies within the critical region, so we reject H null. There is evidence at the 10% level of significance that there is a correlation between the masses of the two reactants. Any questions there?
No.
Okay. How about this?
You have to find the PMCC calculator.
Yeah.
I got R is equal to 0.1149.
Okay. That one, was it?
No, 0.1149.
Sorry. Okay. And B.
10%. Okay. So the correlation is positive. So you have to do H0, P is equal to 0. And then H1, P is greater than 0. No, 0. Yeah. Then you have to find value. So it's one-tailed, and there's 8. I don't know what the value is because it only goes up to 5% for one-tailed test in the tables that we have. So.
Ghost. Let's see. Sample size is 8. It says you should.
Yeah, but it's 10%. We only have, it looks like this.
Okay.
Wait, that might be the wrong one. Because there's a Spearman's rank one as well, but it only goes up to 10% for two-tailed tests. It only goes up to 5% for one-tailed.
Okay. So this is saying that the table should go up. Maybe they just picked numbers that are outside of the table. My mistake. 10% equals 0. Okay. Yeah, but if it was on the table, you'd know what you're doing, I think.
Yeah.
Any questions there?
No. Like last week, I really didn't understand this, but like I did like now I understand it because I did some like questions.
Okay.
So like I understand it a bit better now. So I actually know how to do it. So
Okay. What is part A for this one?
state. Oh, the strength of the correlation, I think.
Yeah. Measures the type and strength of linear correlation between two variables. Okay. B, I think you'll be okay.
Yeah,
PMCC.
calculator. But you need it to do the second part.
Claims that's. Oh. So claims students who do well in their theoretical test also does well in their practical test. I think you're okay for that, are you? Or you want to do it?
Yeah, but you know part D, which is what does that mean?
I think it means 5% significance level.
Yeah, but what does that mean? Give an interpretation. Just write 5%.
It's something that happens by random chance only 5% of the time.
Okay. Okay.
Let's see what they said. There is a probability of 0.05 that the null hypothesis is true. Okay. Yeah.
Okay.
I think you're good for that one mostly. Let's see. PMCC test 5%. Straightforward. Vector. I think that's okay. It's just the table again.
Yeah.
And
they're all like the same type of question, so
yeah.
I feel like once you understand it, it's like okay.
And how do you?
I find like all of this so much easier than last year. It's like why couldn't we have done this last year?
And
Binomial was hard.
that's great. What binomial distribution?
I find it harder than this, like a lot harder.
So you mentioned normal distribution as well. Do you want normal distribution or binomial?
No, I said like association.
That's pretty much it for the association one.
Isn't
Correlation.
association like Spearman's rank test?
So this is Spearman's rank. It's just instead of using the formula, you're just putting it in your calculator.
I thought this is PMCC. I thought this is different. So they're different things, yeah. Because this is correlation, but Spearman's rank is association. It's like a different thing.
Let me check this thing. I was looking at it today.
It might be like called something different in the book. I'm not sure.
No, they called it Spearman. Here we go.
Yeah, it's like a different thing.
Let's see. Okay. So this is Spearman's rank correlation coefficient. And yeah, so you have this formula.
Because you have like in the formula booklet, you have different tables for PMCC and Spearman's rank. So I think they're two different things.
Ah, okay. So this one.
But apparently we don't need to know how to calculate Spearman's rank. Like you'll always be given the coefficient apparently.
Okay.
But like I know how to do it because you have to do it in biology.
Aha. Okay. So do you want to do any of these, or you think you're all right?
I've done those already, but I don't mind doing like other questions.
I think I'd struggle to find other questions.
Okay. It's not that hard. It's the same as correlation. Like the same. You have to do the same thing. So I don't mind if we don't do it.
Okay. Let's see. So the other stuff.
Can we do like hypothesis testing with normal distribution, which I finally understand?
Yes.
It's the first time I understand hypothesis testing.
Yeah, it's just about showing like it's unlikely to have happened by random chance. It's basically, yeah. Just need to find. think it's towards the end. Standard, normal, mu and d. So then you have binomial approximation.
Yeah. I know how to do that. It's
Okay.
just the formulas.
Yeah. And hypothesis testing with the normal distribution. So this is the sample mean,
Mm-hmm.
and so it's just over n. Okay, any idea about this one?
So 6. So H0 is mu is equal to 60.
Mhm.
And then H1 is mu is less than 60. So it's one-tailed. And then, so the mean is 60, and then the standard deviation is 3 squared over 16.
Let's see.
It says 16 there.
So it was, normally distributed, was it?
Yeah.
The mean is 60. And the standard deviation was what, sorry?
3 squared over 16.
Yeah, so that's the variance, sorry.
Yeah. And then, so it says the mean amount is 59.1. So px is less than 59.1 is equal to. So the probability of x less than 59.1 is 0.1151. And that's greater than 0.05. So you accept the null hypothesis.
Yeah, insufficient evidence to reject the null hypothesis, therefore accept null hypothesis. 11.5 greater than 5%, therefore null hypothesis. Yeah, so we change the deviation. The mean might not, so we keep it the same. Yes, great.
There was a question I just remembered that I actually wanted to go through.
Yeah.
Because I did it, and I think I did it right.
Okay.
And like my friend checked it as well, and he said I did it right, but the answer was like different.
Okay.
So I'm not sure like how they got that answer.
Is it in the book?
No.
Okay.
I could like read it out.
Yeah.
It's not very long. A machine is set to produce rods of length LCM with the distribution Ln. Mu is 10.6 and
Hold on.
standard
L is normally distributed, is it?
Yeah, 10.6, comma 0.8. Yeah.
And is it 0.8 squared or 0.8?
It just says 0.8, so I'm guessing that's the standard deviation. Maybe that's where I did it wrong, because I assumed it was like the standard deviation.
That's the variance, and so what would be standard deviation?
That makes a lot more sense.
Yeah.
So standard deviation is zero. So then, like, the sample mean would just be 0.8 over 50, right?
I didn't get that far in the thing, but
Oh, yeah. A check on 50 rods showed a mean length of 10.79. 50, 10.79. Why would it be less than?
oh, I don't know.
Greater than.
I'm having difficulty
It's
following.
two-tailed. Because it just says carry out tests to find out whether the machine should be recalibrated. So it's a two-tailed test, and it should be greater.
So what came after this one? 10.6, 0.8?
A check on 50 rods showed a mean length of 10.79.
0.79. And so, yes.
So that's where it's wrong. It's like that isn't the standard deviation.
What is the standard deviation?
No, like 0.8 is the variance, not the standard deviation. So when you do the sample mean, I did 0.8 squared over 50, but it should be 0.8 over root 50, right? Over 50.
It should be square root of both.
Yeah.
Yeah, root 0.8 over 50, all thing.
So mu is 10.6. That's where it went wrong. I was like, how did I do that? I didn't understand.
And see if the answer matches up with what they got.
Yeah. Yeah. No, it still doesn't match up. I got 0.286, which is so wrong. They got like 0.067 something.
Might be something to do with the two-tail thing. Let's see.
I think it's because, wait, I think I know why. Wait, I'm just going to try it and see if it works now. Because I think it should be. Oh, I got it now.
Yeah.
It's because it should be 0.89 over root 50 and not root 0.8. Wait, that's the same thing. I don't know, but it worked now.
Okay, maybe you just
Or maybe I just put it into the calculator wrong or something.
It might just need to be in brackets or something.
Yeah.
Because I noticed that when it's putting it doesn't put in a fraction, it's in a linear mode.
Okay, I got the answer right now, I think.
Yes. Good.
Because we were so confused because like it looked right.
And what standard deviation did you use for the previous question? Do you know? Did you write it down?
What previous question? Oh, this one. Wait, this one.
Mm-hmm.
Oh, I did 3 squared over 16. But standard deviation was 3 over root 16.
Yes, and so that's right. I wrote it as 3 squared over 4 squared. Square root of 16 is 4, and so it's just 3 over 4. So just it's always given in the format mean and variance. And so you just have to remember to...
Because sometimes it should, like most of the time it says something squared.
Yeah.
So it's just really confusing.
I noticed for whatever reason at this stage, because it's kind of like the final stage of normal distribution, they have a few questions where they don't do that.
Okay. I will pay attention next time.
I think you'll be fine for this one. It's pretty much the same. Let me see this one. Random sample. Mean is 12.4 greater than 9.5. I think it's just the wording is a bit weird, but other than that, it's okay. Of course, X population. I suspect you're going to be fine for this one.
Mm-hmm.
And give one criticism of your conclusion to part F. So is this the reading scores of 7-year-olds? 50, standard deviation 8. An extra 20 minutes a day will improve reading scores. A random sample of 12 children are chosen and instructed to read for an extra 20 minutes a day for a month. They're then tested to find their reading scores, and the mean score is 54. So what one criticism could we come up with?
The scores might not be normally distributed.
Oh. Yeah, of the conclusion.
Oh.
So it's given that they are normally distributed.
Not sure.
Let me see. There could be other factors.
Oh yeah, that could affect reading score.
Like certain students might kind of drop out of the test because they're not able to do an extra 20 minutes, but the kind of students who are able to do an extra 20 minutes of reading are probably better, better off in general or something. Increase could have been due to other factors, e.g. second time taking test increases familiarity. Yeah, that's a good point. Yeah, because they took one. So this is kind of critical region stuff.
I don't know how to do that, so I need to go over that.
Okay, let's see this one.
For any of them, I don't know.
Oh, so it's very similar to the standard normal distribution, except it's Z is equal to, instead of X, it's X bar. So the new mean, sample mean, minus original mean over sample standard deviation.
Okay, I will try and remember that.
I'm going to just copy this in case. Okay, let's try this one.
Okay, so Z. How do you find what Z is? Or do you don't need what Z is, right? Or do you?
You might. I think, so Z.
Is Z what you're trying to figure out then?
We could, there's a much easier way around it, which is to use the calculator.
Yes.
And let mu be 0 and standard deviation be 1.
Yeah, I know how to do that and find Z. But I don't understand this formula.
You didn't even try the question. So it's usually...
You just is Z what you're trying to calculate? That's the question.
You didn't even read the question. You don't even know what it's asking.
Find the critical region. That's what it says. So the sample mean is... It doesn't tell you what... Oh, you're meant to find the sample mean in this question, I think.
Great.
It doesn't tell you what it is.
So how do we do it?
So Z is equal to sample mean minus 0.58 over 0.015 over root 50. Yeah.
Okay.
So you have to find what Z is, but I don't understand how you do that because you don't know any probability.
I think you just said 3 variables, did you know?
Yeah, but you don't know 2 variables, so how do you find?
Oh, I don't know. I wasn't... So Z equals sample mean?
You don't know what the sample mean is.
So that's X bar machine. Changing my flow. So D is normally distributed. Mean is 0.580. Standard deviation is 0.15, so variance would be squared. Machine is serviced a random sample of 50. N equals 50. From the next production, the mean diameter has changed from that. The distribution of the diameters of both sides is still normal with a standard deviation of this. Find at the 1% level the critical region. If you need to find a critical region for a hypothesis test, you can standardize your test statistic.
Isn't there another way to find critical region? Like, do you have to do standardize the test statistic, or is there another way?
I use a different way. I just don't remember off the top of my head. What did I do? There we go. That's what I did. Inverse normal.
Okay, what do you do? Oh, I know this. It's like you have to do 1 minus the significance level or something. And then, wait, that's for the top tail. It's two-tailed. So you have to do 0.005 and then 1 minus 0.005 for the top tail. Right?
Not with a graphical calculator. You can just change the tail to right, or you can do it that way, keeping it to left.
And then you just find, okay, so then if it's like the, okay, I think I get this, but not really.
Do it.
So 0.005 distribution.
So the standard deviation, yeah.
So for the left tail, I got, which is less than, right? I got 0.5745.
745. And that is the x is less than, isn't it?
Yeah.
Okay, right tail.
And then greater than is 0.5855. Wait, is that all we have to do? Oh, that's so easy. But then what if it's one tail? Do you just do like whichever direction it is with the significance?
Yes, and you don't have the percentage. You don't have the probability. How about question B?
It's calculated to be 0.587. So 0.587 is in the critical region.
Mm-hmm.
So you would accept.
What was this one? Sorry, 0.58.
5855.
Okay, so 0.587 is within critical region.
So you accept H0? Or do you accept H1? I get confused.
You accept H1 because it's a very, very unlikely.
So if it's in the critical region, you reject H0.
Yeah, and accept H1.
Okay. I'm going to get confused now because I have to remember like 3 different ones. Because the correlation coefficient one is different from normal hypothesis. It's like the opposite of normal hypothesis testing. And then this one is like different as well. So I'm going to get confused.
So just to make sense of it, there's a 0.5% chance that if you took 50 randomly, that the mean would be 0.587. And so because there's like a 0.5% chance is so unlikely, then the mean has changed.
Okay.
I will build it up. Okay, let's try this one.
Find the critical region. You don't know what mu is? Oh, you do know.
So
Right.
they do
So,
word them quite strangely when you get to
so
the end.
it's two-tailed again. So you just do one tail and then you do the other one.
Yep.
34 and then 1.1. Wait, no, not 1.1. 1.1 over root 25.
Yep.
And then the significance level is the same as the previous one. So x is greater than 34.567 and less than x is less than 33.433.
See?
Result. How do you know what the result of the hypothesis test is?
Oh. A sample size that is taken and is used to test this and state the result of the hypothesis test. Is that connected to part C? I think it might be connected to part C, is that right?
Yeah, because you can't do it if you don't know what sample mean is.
And so, what is
So
part C?
x is in the critical region, so you accept H1.
Yeah.
Wait, is it in the critical region? No, it's not in the critical region. You reject
33
H1. You reject,
points.
yeah, you reject H1
Okay, yeah. So,
if you accept H0. Sorry, I just read like the bottom line wrong.
critical region. Yeah, so insufficient.
So you reject H1. I'm actually going to get confused with this in the test.
Yeah, so it's something that's like not that rare. Let's see. So part B, yeah, they just worded this strange. It's not in the critical region, so accept H0. Great. One tail test is used
In
to
an
test.
exam, would you be allowed to do that? Like look at the later parts and then use it to answer? Like
They
need to there, I think.
that's a bad question.
Okay.
That shouldn't be there. That should be, yeah. And even then, like, comment on this observation. I mean, this is what they meant to say. State the result of this observation. That's bookie.
It's really annoying.
Let's see. After
And
this,
it's just a test. It doesn't say significance level. If it doesn't say critical region, I'm not doing critical region, so
so let's see this one. Upper, lower, normal cumulative, easy peasy. That's what that looks like.
I have to think of them.
5% of pulse. They all look the same, these questions. Randomly chosen bolt can be
I think I've done
small.
this question before.
Are these questions in the right place? Maybe they're not. I don't know. Find them. No, these are all the sample mean.
Yeah, it's like
They're just not critical region.
I need to do like critical region.
Oh, you destroyed that last one. Determine the maximum in order to reject. That's critical region.
Really?
Yeah.
Oh, you accept H1. So you just find critical region. But it's less than, so you do to the left and then you do 0.01 and then 12 minutes. So x is less than 10.33. So that's the max. Because if it's not in the critical region, you reject H1, right?
Yeah.
So if it is in the critical region, then you accept H1 and you reject H0. Okay.
Yeah.
I'm getting this, kind of.
If factor decides to test observed a mean
That's
range.
such an easy question. Why is it 4 marks? Like you
Uh,
put it in your calculator.
Historically, you couldn't put it in your calculator, and so there might be a year
That's
or two where they adjust it.
okay. Fair enough.
Let's see. Oh yeah, how about this one? Question C.
12.3 is not in the critical region, so you reject H1 and you accept H0.
Yeah. Basically, insufficient evidence to reject the like default hypothesis, and so yeah.
Wait, don't you reject H1 and... Oh, okay.
Yeah.
Just got confused because you reject H0.
There's insufficient evidence, so yeah, so it hasn't changed. And even more exam questions. Write down the distribution. Oh, what's this about? Oh, that's easy peasy, I think.
That just sample mean and then sigma over root n.
Yeah. Oh, how about B?
Region.
I don't think it is. A bit different. Something a bit different about it.
Oh. I don't know how to do this.
There's a few different ways to do it. I think the easiest way would just be
inverse normal.
Sorry?
Would you use the inverse normal?
You could also just do trial and improvement. That's probably how I would do it.
Mm-hmm. How would you do it with the inverse normal?
Let's see. So what do we know?
0.9. Wait, no, that's the wrong mode. So I only see 0.95.
95% certain.
So the area would be 0.95?
No.
How large?
No. 95% certain equals 5% significance. We want something that is very rare.
So you can't do 0.95 as your area.
So what is our area?
0.05 as the area.
Yeah.
Okay, and then would it be less than or greater than?
Let's see. On the distribution of sample mean. A machine in a factory makes metal sheets with width that supervisor wants to.
But you don't know what mu is, so I have no idea how you would do this question.
Determine how large. Well, it could be.
You'd have to use z equals x minus mu over sigma, yeah.
Could be that.
But you don't know what x is either.
Determine how large a random sample is needed.
You're trying to find x? Oh, you are trying to find x. I think
we're trying to find n.
N? What's n?
In the calculator will differ from the population mean width by less than a centimeter.
I have no idea.
And it's 21, is it? Let me just take one last look at this. So the width is x. X is normally distributed. We're assuming mu and standard deviation is 3.2. Determine how large a random sample is needed. So 5% will be different from the population mean width by less than a centimeter. I think you could do standard normal for this one.
So 0, 1, yeah.
Yeah. So that's 1. That's 0.
Yeah, so that gives you z, and then you can find what x is.
Yeah.
But you don't know what mu is either, so. You have two unknowns.
It
One
says
equation.
will differ from the population mean by less than 1 centimeter. So I think that would be mu. The magnitude of mu is less than 1, meaning mu is between minus 1 and 1.
Why would it be magnitude of mu is less than 1?
It says the population mean width. Sorry. The sample mean width will differ from the population mean width by less than 1. Oh, so the difference between them is less than 1. Wow. So the magnitude of
Sample mean minus.
will be less than 1.
Okay.
This strikes me. This is nothing like the other exam questions.
This is like old spec because I have no idea how to do it.
Yeah, it's not supposed to be old spec. It's supposed to be new spec, and in fact,
okay, never mind.
But it's like from they put out a bank of exam questions, but they're not past exam questions. So I don't know if it would make it into a real one. This is definitely the thing where they show a student does it wrong, say what the student did wrong. That's definitely new spec.
Mm-hmm.
Okay, well, what's A?
Oh, I know this one. When n is large and when p is close to 0.5, I think.
A is roughly equal to 0.5.
I'm not sure if that second one is right, but I definitely know n is large is right.
Sounds good to me. Yep.
Oh, yay. Oh, I found a mistake already.
Go on.
When they did sigma, you have to do square root of 250 times 0.48 times 0.52.
The incorrect calculation. Yeah, they should have done square root. Use a normal approximation to find the correct.
Just correct the mistake, basically.
Yeah, he'll be alright, I think.
So when you do normal approximation, is that the only time when you have to do like 129.5 instead of 130? Or is there like other times when you would need to do that?
There's other times. Maybe they're in year 1.
We didn't do this.
No. It's a table of data. You might have something like 128, 129. Estimated mean?
Oh, like group data.
Yeah, groups data. And so this is like flower height or something in centimeters. And so you just have to, for let's say this one here, the 130. If it was 129.1, it would go in this box. But if it was 129.9, it'd go in this box. And so you have to stretch it out and say it's 129.
So you only do it for group data and normal approximation?
Yeah.
Okay. But how would you know if it was group data? Would they tell?
It's for basically for continuous data.
Okay.
For continuous.
Okay. That is like it could be anything.
It can always be measured more closely.
Okay.
Whereas if it was like people, you'll never get 2.5. It'll be 1, 2, 3, 4.
Yeah, you kind of 2.5 people.
Yeah, and so basically they rounded the data, and so you just unround it.
Okay.
Like lower bounds, upper bound. Yeah, continuous data. It's when you use it. Let's see this one.
Probability. Don't like it. So for critical region, I'm just going to ask again because I'm so confused.
Oh, you want more critical region?
Yeah, because I don't know how to do that.
So this is, you just did it a million times. Find the
But like when it's in the critical region, you accept H1, and then when it's not, you reject H1.
Yeah.
Okay, I'll just remember this in like H1, so then it's easier.
Okay, and it's just weird the way you're saying you would reject H1.
I know, but like it helps me remember it.
Okay, because like the default is like H0. That's just the same.
Yeah,
You
but
assume.
then if I know it's reject H1, then I know it's accept H0. But I don't want to get them like mixed up.
Okay.
It just helps.
For probability, given that the bag is not reserved for probability, find the weight that is exceeded by 1% of the bags. This one is kind of
Oh, that's inverse normal. I know how to do that.
Yeah, that's just inverse. You're too good.
I'm really not, but
Find the value of mu and d. Is that worth doing?
that's simultaneous equations. And z is x minus mu over sigma.
Find the
I was so annoyed. I thought my test was going to be today.
Why? When is it?
I don't know. My maths teacher, she's so annoying. She's like, it's sometime this week. It's not today, but it's sometime this week. It could be tomorrow. It could be after that. So we don't actually know. It's just really annoying.
Suitable approximation?
Is that binomial, like normal approximation?
Yeah, that's binomial approximation.
Oh, binomial approximation.
Yeah.
How do you go from normal to binomial?
Great question.
I only know the other way around, like binomial to normal.
Let me refresh my memory. Maybe it is just one way. Let me see.
Yeah, I want to do this like np 1 minus 2. But
yeah, so it's just that. You don't have to do it the other way.
How do you do the question then?
Was it that way? Probably not. Was this using a suitable approximation? Yeah, it was this one.
What other approximation is there?
So the amount of mineral water in a bottle, normally distributed. Find the value of mu and d. The bottles are packed in boxes. And then so you just do it the normal method, I believe.
How? Px is less than 250.
Yeah.
Okay. But then why does it say using a suitable approximation?
I don't know.
Okay.
So you just get mu d.
Sigma, yeah.
Yeah. I said
it's not d.
And your sigma. Most students don't like hearing sigma.
I don't care.
Let's see. Find probability. Let's see if there's any suitable region. Yes, so that's estimated mean, estimated quartiles is...
Yeah, you just put 0.75 and you do inverse normal, right?
Yeah.
Or like 0.25 or whatever.
Probability.
Oh, that's the same question that was there before.
Mixed exercises. This will probably have critical region stuff. It should be probably towards the end though.
Because it's hard.
Because that's... everyone was at the end. Okay. Hang on, let me just see this one. Mean of a normal distribution. Oh no, that's easy peasy. Distribution of a sample mean.
Oh, God. I don't know how to do these questions.
What's different about this one?
I don't know. It's two-tailed. What's different?
It's part B is the different bit.
I don't see anything. Oh, assuming that the standard deviation is also 0.19. Is that the different bit?
I believe the different bit. Well, what is mu?
Oh, you don't know what mu is?
Yep.
Okay. How do you do it if you don't know what mu is?
A girl in year 7 with a calculator would know what mu is.
But that's the sample mean.
What do you think a sample mean is?
What
do you think?
Like calculate it or like?
Yep. A sample mean is just the mean of the sample.
Yeah, but you can't use that in the hypothesis test. Like that's the thing you're testing, but you need another mu. There's always two mu's.
Part A had a mu of 4.11.
Do you just assume that it's the same?
It is the same. They said it's the same.
What?
This is a sample from these eggs.
I don't think this was a sample because it says assuming that the standard deviation from this island is also 0.19. So
A sample.
yeah, but it could be a different island. You don't know if it's the same. It only says that assume the standard deviation is the same, but it doesn't say assume the mean is the same. So how can you assume?
You don't assume the mean is the same.
But you are assuming the mean is the same because using 4.11.
So that's the assumption, and then you would test if the mean has changed. So the mean of these.
Okay, that makes sense.
So the mean of these is the sample mean.
H0 mu equals 0. This is some critical region though.
You and your critical region. You're good for critical region. The only thing that's different about this is they don't give you the mean of the sample. And
Yeah,
so you just have to
I've
do it
seen
yourself.
questions like that though. So
Okay. Well, anyway, I think you're good. Yeah, how was that for you, Amogha?
pretty good. I sort of know critical region. I hope it doesn't come up in our test.
You can't. There's nothing more to know about it. Anything in particular you want to do next time?
Oh, we're doing this like integration thing, but it's kind of like chain rule. I don't know what it's called, but it's really hard.
Reverse chain rule?
No, it's like integration by substitution, I think.
Okay.
It's like a thing.
Yeah,
It's confusing.
That's a tricky one.
Like I can do it, but I have to copy it like from the previous question, so I don't actually know how to do it like by myself.
Most of the time, they will give you the substitution to use.
Yeah, I know that, but like the steps and stuff, like I don't know how to do it.
All right, we'll go through it.
I have to like copy it from like the question before.
Mm-hmm. Nothing wrong with that if you can get away with it.
Yeah, but I need to like actually learn how to do it because I know it gets harder.
True. Any questions for me in general?
I'm fine.
All right, well done, Amogha. You did
You.
great, better than you seem to think, and look forward to chatting again next week. All right, have a good week. Goodbye. Cheers.